Hello guys, let's do some programming here just because we love it. So here we are using Turbo C++ just because we love it. So here what's the problem? We have array A and array B, two sorted arrays, and we want to merge it. The output is C, as you see here. So the output is two sorted arrays in only one, the merged one. So let's see if we have here what we have here in this old programming tool. Let's see if we have IO string include IO string.h. Let's see if we can print something. Let's see, cout hello world, and we're gonna use this. Okay, now let's compile out C, compile, okay, compile, and out R uh, run, Control plus F9. Okay, it run, Control F9, it run instantaneously. So I think the problem is that the is outputting and the program is exiting so fast. So let's read something from the keyboard to hold the program there. Let's let's just read an integer just to hold the program there. Let's see. Alt C, compile, success, Control F. No. Okay, there. You see? Now we're printing hello world. Amazing. Now let's clear that. I think, if I remember well, is conio the function. Yeah, let's see. I want to print that string because it will be printed as it is now. Let me show you guys. If I run this program again, it will print. Let's compile there, compile, success, and run. It's printing many hello worlds, and the screen is being printed, not being cleared. So let's clear it. For that, we have a function called clear screen. It's like this, and the library is include conio.h. Let's see if this is the function. Errors. No, this is not the function. So I think the name clear. I think this is the name of the function. Yeah, that is the name. You see, now we have hello world. Okay, now that we know how to print something, let's do this merge. So I'll name this the merge algorithm. Let's rename it to merge two arrays to sorted arrays algorithm. Okay, this is just for the end, and what we're gonna do here is the algorithm. So first, let's create that arrays. So they are integers, so let's create an array of integer. Let's say it's array A, and put that values 23, 47, 81, 95. And now we have array B. That is 7, 14, 39, 55, 62, 74. Okay, amazing. Let's see if it's still compiling. Errors. Determination declaration terminating correctly. Oh yeah, here I'm putting the wrong character there. Let's see. Hmm, Let's see. This is the syntax. This is the syntax in C++. Yeah, that was the syntax. I I work with many languages. Sometimes I confuse the syntax. So now we have two arrays and we want the other array but merge it. So let's see that we now want the array C. And how many parameters we have here? Let's do this now by simply counting it. 1, 2, 3, 4 plus 9, 10, 11, 12, 13, 14. 14 elements. Okay, now we have an array of 14 elements. And here, let's just do a simple for here, just to print that what's in that array. Simple as that. After we change the algorithm to be more generic, but by now we just want to make it work. Let's say cout on the position I and array. The value of the array, final value, now will be anything here, just to print to see it looping. This is our output. Let's compile. Errors. Statement missing semicolon. Okay, because we need the minus sign here. Okay, it's compiled. Array bay is assigning the value that's never used. Okay, I know that. Now we're gonna use it. So how we merge that two arrays into array C? If they are sorted arrays, we want to loop in each of them to make sure we're getting the index, I think, to put in the array C the value based on the index that is the most recent and the value is ordered. So let's do the algorithm. What I think, for example, we have index A begins 0, it's sorted, so let's begin 0, index B, and we also have index C, that's 0. So what we're gonna do now is to loop. Let's see a function if we can get the size of that array to see if this is the correct function. Size of the array is size of, if I remember well, this is the function, array A. Size of returns the size of this array, for example. But if I want to look for every element, I want to get the size in bytes of every element. So just let me show you. Here we gonna print this value, this pure value, size, and there is another stuff that we're gonna print is the size of index. Can be any index of that array. So size of array on position 0. So we'll get just the value of one position. So for example, we get the size of this element here or this one. Every element will be the same size. So if we want the length of the array, we have just to divide the size of the whole array by the size of element. Normally, this is done like this. Size of array A divided by size of array A on position 0. So this will print me the number of elements of that array. Let's print length here and length 2 just to show the number of elements of that array. Okay, let's compile. For now, we're gonna just comment this code here. That is the output, desired output. Let's compile, okay. And now let's run it. Control F9. You see the size of the whole structure is giving 8 and the length is 4. Let's take a look. So guys, I take a look at this. So what's happening here is that this is running in a DOS emulated system. So DOS has 16 bits. So the word, the int value has 2 bytes. Each byte has 8 bits. So we multiply 2 by 8, 16 bits. So this architecture is 16 bits and we're giving the value of 2 for each byte, for each value of this array. That's an integer. But this was not related to our problem. Let's just get rid of all this thing. We just want to get the length of the array to iterate over that array. So let's clean this up. And we just want the length here that is more or less like the size of array A by size of the first element of that array. So I've been surprised by that because we are very used for the integer to be 4 bytes that this is kind of weird to me. So here the length of array A, and we also can get the length of array B. size of array B, and of array B. So we now know the length of this array B, and maybe if we do like this, we can create the let's remove this from here. Cut this shift down, and we have shift insert old stuff. I think now we can create a const here. Len C, that is len A plus len B, and put the size of the array C with the correct size based on what we compiled before. If we put const here for both of these values should work. Okay. Now let's do the merge step. So what we have here, what you're gonna do is to make a loop between two arrays, seeing the one that is uh, less we're gonna check here and see the one that is has uh, the minor value between them and put in the new array. So let's iterate in let's do a loop here. I'm thinking how to do it. So let's say that how we can do it. I think we can do with while loops. Yeah, I think it's better. While what I want to do here, let me explain to you guys. We have index A. I'm gonna search for every element here and compare with the current one that's on the other list. If this one is less than the other value, I'll put in the list and increment and get the newer one, and so on. Now, for example, here we get 7, 14, the index is 2, and once we find the next one, we compare the two arrays and we get the last value and we increment the list. So this is what I'm going to do now. So while index A is less than len A and index B is less than len B, we have elements in this list. So let's do it now. If let's put the current value for each array. Array A on index A is less than array B, index B. If this happens, I put this in the list. So this is happening now. What I'm gonna do is to put this value on array C, index C. plus plus. I'm putting it and incrementing already. Array A, index A. And I also increment index A here because I'm getting the newer one. Okay, this is perfect. Else, the contrary is happening. Array C, I'm gonna increment it with array B. And, and I'm also increment the index B. Okay, I think this is gonna work, but let's see. Let's see first if it compiles errors. Okay, just putting wrong values there and here. Okay, okay. I think this compiles, but this algorithm is not going to work because, for example, if we stop here, for example, if we have these only two values here, it will put the 7 because A is minor than 23. Okay, now we get the 14th element is minor than 33. We'll put it, and now it will put 23 because it's minor than 39. And after that, we remove the 39 because it's minor than 47. Okay, this is still working. Now, 47 is minor than 55. It will work. We'll put 47. And now this is not going to work because it will stop here because 55 doesn't have it is not less, um, the value is not minor than the other value, so it will be stuck here. So how we can solve this? Let's take a look. Let's think together. Okay, this is kind of tricky, I think we can do this till we have one of these elements done. So we can put R. So let's see if this works. If I 55 element now, and I come back here, I have index A is minor than length. Yes. No. Oh man, this is going to work. It was right because do you see? I'm incrementing the index here. When I came to 47, it will break this while loop. So what's happening here is that if we have an index Let me show you guys what's going on here. First, I was thinking that this is not going to work because it will stop on element 55 because he can't compare between other elements. But actually, this while structure here, it's okay because we have we are checking here if index A is less than the length A, or and better saying index B is less than length B. So if one of these lengths are out of this array, he stops here. So he will stop on 55 because index A in this moment here is 2. So yeah, it's okay because you see the length of A is 2. Length of A is 2. Length is 2. And the index of A when came into this point, 55, it's also 2. So index of A is not is not less than length of A. So it will stop here. So the solution for that is continue inserting the elements that are outside of this uh, loop here. So we just have to repeat the length of A, the array, putting the elements that are remaining in the list. So for example, here we have array of A, putting here the same structure, and here also we have index B less than length of B because we are we are wanting to insert the remaining elements. For example, 55 to 74 is the ones that are remaining to be added in this moment, and it will skip the values of A because here the index A is 2 and the length is 2. So it will not continue inserting anything. It won't enter this loop. But it will enter this loop because the index of B now is 3 and the length is how many elements we have? 1, 2, 3, 4, 5, 6. So from 3 to 6, it will put the values in this array of C. And let's print the result of this algorithm, make sure it's working. So now that we have the length of C, we can print everything. Let's compile it. Success. And let's run it. Yeah, let's see. 7, 14, 23, 39, 47, 55, 62, and 74. And this is the merged sort of two of these two algorithms. Yeah, that was pretty cool to do, guys. So this is my first video. I hope I'll do many videos. This was a pretty simple algorithm. I think we're gonna do the simpler algorithms first after we gonna do some more complicated ones. But I think now we learn many things here from array stuff to sorting and understanding the structure of the arrays in C. I think this is pretty good knowledge that is very necessary. And also we have like we know the size of the integer in this is in this old architecture. I think it's very important to C++ programmers and C programmers to know what's going on behind the scenes because, for example, many Java and C Sharp uh, boys don't even know the size of things because many programs this is not really required. Even though this is very necessary for some optimizations, but of the many uh, of the but many times they just need an integer, for example, to calculate a sum or something of something. So it's very interesting C++ to know how things happen behind the scenes. And this is pretty simple, but in the end, we're gonna learn many new things here with this channel. Thank you guys. We did this just because we love it. Bye bye.